Ladies and gentlemen, good afternoon. Thank you for being here. I am part of a team number 6 who work on the IDog. Myself, I'm Emanuele Colognato, Lazaro Sanchez, Cesar Nunez, and Zhang. The IDog. We are trying to interact with you. People interact with the dog and have some we implemented in this robotic to basically get feedback to the users when the dog is being pet, for example, or using sensors. Different sensors have been used for this project, but the implementation goes really a lot. The outline for this project is why the IDog, the description and team responsibilities, the specification for this project, the program flow chart and the demonstration, and the improvement and conclusion that can be done. The team responsibilities are the assembly. I myself worked with Lazaro, the program, Cesar, and Lazaro, and robot testing. We all work together to get everything working as it should.
Well, I'm going to talk about the problem statement for the IDog. So basically, our mission was to actually program a robot using PBasic, the given Bobot starter kit, and to follow simple commands which the user is given, and it will interact with the user itself. So pretty much why we wanted to do this is a study in the St. Louis University shows that people living in retirement homes, when they interacted with such products already out in the market, it showed that their loneliness was actually decreased. These robotic dogs actually give the people which are, say, reaching their terminal ages more comfortability, and they were actually happier also.
Well, are some of the robotic pets that are currently in the market. For example, the Tiger Furby. It's a kind of robot that just interact with people with the ultrasound sensor and singing songs. The Sony IDog, it's one of the most advanced robots that are right now in the market. It has voice recognition, ultrasound sensors, touch sensors, and it works very, very well. And the just touch sensors. It moves and interact with the user, just with touch sensors. The description of our design, our robot IDog will be able to lay down, sing, different types to interact with the user, bark, and acknowledge when being pet. The specifications of our platform here is 40 centimeters by 10 and 20 centimeters. The servos and the platform can hold a maximum weight of 1 kilogram. The batteries are regular batteries, rechargeable batteries, and the runtime of these batteries probably around an hour. These are the components that we use to build the platform. We use acrylic for the legs, the ultrasound sensors, the Bobot, the kit Bobot that everyone bought in the project, the deep switch, and the electric speaker. Now Emanuele is going to explain to you about the assembly.
Here you can see some pictures of us trying to come up with different. I'm right there. You can see me on the upper left picture grinding the outer edges of the leg to remove any kind of deburring the material. Lazaro here is cutting the legs and panels, and here we're trying to drill the holes because we mounted the legs right on the servo using provided plastic pieces. And this is the final assembled design. The IDog is standing up. Here is a sitting down position and laying down.
Alright, now we'll talk about the program flowchart for our IDog. So we can see these are mainly 3 different programs actually. It has the main program, which starts the initial checking of the sensors. Then it becomes to the SIP program, where it's another different program checking another sensor. And then another program to check for the laying down, and then the final sensors that it checks on that. Pretty much what we wanted to do was, at all times, we want to check for our touch sensor being actually pressed. If it is, it will bark and acknowledge that it is being pressed. And then also the other sensors in which it goes to, say the sit-down mode is when it has the ultrasound, and also the photoresistor, which will lead it to the lay-down mode. Next. And then
the conclusion. Currently, in this design, the IDog can perform these commands. It can sit, as you see it here. It can lay down. It can acknowledge being pet, and it can speak, barking, and sing. And this concludes our presentation. Some improvement that are include the sensor for knees with 4 degrees of freedom that you can see here. It's very challenging to perform any actions, specifically walk. The major feedback that we can have from the robot is actually to interact with the users by speaking or barking or singing. So include a real speaker. We're using a piezoelectric speaker here. If we can include a real speaker, then the frequencies will be much better. And also the touch sensor, we would like to use some kind of a LCD panel or touch panel where you can actually pet the dog and it can feed back to you. And thank you so much.
This concludes the presentation.
This concludes the presentation.